Robotic Process Automation, or RPA, is a technology that allows you to develop a script that interacts with other programs and automates their activities. Since its humble origins decades ago, RPA has matured in many ways. Particularly, it matured into the use of Visual Basic scripts hidden behind Excel spreadsheets. So, for example, if a financial analyst needs information from a collection of screens on the mainframe, someone, either they or a subject matter expert, might write a script that would then interact with perhaps hundreds or even thousands of terminal-oriented transactions to obtain the data. What the end user then sees is that data being populated into that spreadsheet. With a formal RPA platform, they can interact with the mainframe through screen scraping. They can interact with web-based applications by scraping or extracting information from HTML screens, or they can interact with other API-based services. The impact is very simple. That is, what we see happening on the mainframe are transaction volumes that are huge relative to the underlying business activity. So as organizations deploy RPA platforms or other types of RPA, they run the risk of driving up their transaction volume needlessly. And the problem is an organization sees this asymmetric increase in their KICS transaction volume, but frankly, they don't have a lot of information to determine where it's coming from, why it's occurring, or what is the business value of all of that transaction activity. Earlier this year, I was invited to come on site to a large organization. They're a worldwide enterprise that uses mainframes and is a heavy KICS user. They were concerned that their transaction volume was growing at a rate that was drastically above what their actual business transaction volume was. In looking at their SMF data, we discovered a heavy, if not predominant, use of RPA things, macros, scripts, and bots that were driving the lion's share of the interaction with CICS. As a result of our work with that customer, we developed a tool. And this tool allows us to see exactly what is going on. We can determine what are those robotic processes, where are those robotic processes, and even more importantly, what are they doing? When we did the RPA analysis using their data, it became very clear that individual users across their organization over the last decade had sought to self-solve certain problems or requirements to obtain data that they needed to do their job. And while that's very honorable, that shows great initiative on behalf of those end users, the problem is by the time that initiative showed up on the doorstep of the mainframe, it was doing things in the most inefficient way possible. In this customer's case, the very first one we looked at was an RPA bot that ran a menu transaction one time and then a transaction to get pricing information or item information 6,734 times. I don't think it's any stretch of the imagination to think that there must be some better way, more efficient way than running almost 7,000 terminal-oriented transactions, each requiring a full travel across the corporate network for that end user to be able to obtain that data to do their job. This does not invalidate RPA. This does not mean that an organization should outlaw Excel scripts interacting with CICS or should not use a formal RPA platform. It simply means that when they point the power of that tool at the mainframe, they need to do it in a way that is optimal and smart. So to the RPA vendors, we think the power of their platform to help organizations optimize their business processes is clear and compelling. And to the enterprises who are already using various forms of RPA, perhaps including a formal RPA platform, our advice is very simple. Be careful. Make sure you're communicating from the RPA platform or that script to the mainframe in the most efficient and effective manner possible. Let's go back to that example where we had an organization implementing an RPA component that ran 7,000 transactions to do a business process. What's wrong with that? Well, first of all, we're orchestrating a business process on the mainframe in the least efficient way possible. We are using a software component outside the mainframe to be able to orchestrate each step, thus requiring an individual send and receive of the response 7,000 times. Another problem with this approach is that 9 times out of 10, what the RPA bot or script is interacting with on the mainframe is a terminal-oriented transaction, and it is integrating to that transaction using screen scraping. First, we can help you see the RPA activity that you have today and monitor RPA activity that you may have in the future. And that particular monitoring tool not only lets you know, yes, it's occurring, or no, it's not, it shows you exactly what is occurring. So you'll know the exact sequence of transactions that various RPA elements are using. Second, once you know the DNA of an RPA bot, you can then consider remediation strategies. For example, when we showed that very simple DNA to our customer, and they saw that end users were writing bots and scripts to be able to get extracts out of their pricing catalog, they immediately realized they had a business requirement, and secondly, that that business requirement could be met in a far more efficient way. Instead of running 7,000 transactions, run a handful of DB2 requests. As a result, latency drops to the floor. CPU time goes way down. Now, in some cases, automating a sequence of terminal-oriented transactions in order to accomplish a business benefit or obtain business data is the only way to solve that problem. However, as a general rule, orchestrating terminal-oriented transactions off the mainframe and using screen scraping as the means of integration is never a good idea. By doing automation on the mainframe, the first benefit is the complete elimination of all that built-up latency to exchange thousands of requests and responses between a client, a server, a bot, and the mainframe. Instead, that bot or server or script sends a single request to the mainframe. We then do the automation on the mainframe and return one single response. Another benefit of doing the automation on the mainframe and under the covers of CICS is that it allows us to interact with those terminal-oriented transactions such that we can eliminate screen scraping. And the best part of all is that the RPA platform doesn't have to change, nor do the mainframe applications. They don't have to change either. All we're doing is moving the point of where the RPA is occurring, instead of trying to do the automation and the orchestration outside the mainframe in an inefficient and brittle manner. We want to do that inside the mainframe in an efficient and flexible manner. And although you're doing automation work on the mainframe, since HPJS is zip-enabled, your IT infrastructure costs will not go up. So if you're an organization that has any kind of RPA, we have tools to help you understand what's going on and how to improve its efficiency. And if you're an RPA platform vendor, we'd love to partner with you.